Hi everyone. This is the first of a two-part presentation. Although brief, it's got a lot of stuff in there, including a starter, teaching points, practice questions, and exercises for you to submit on summer homework. To benefit greatly from this presentation, it is important that whenever you see the pause symbol, you stop the video and follow the instructions, after which you can press play to resume with the presentation. How to problem solve change in ratios questions. I like to think of key question in terms of coming up with the keys to unlocking a somewhat complicated question. Hence, I've put at the start the Alice Olivia problem because it clarifies our key question by giving it some context. And secondly, it's an indication of where we are heading with this presentation. Trying to unravel how many sweets each of them had at the start as a result of ratio change sounds complicated. The good news is, if you're familiar with equivalent fractions, solving equations, and rearranging formulae, then you've got those keys in your possession. That means that you're ready for this presentation. Question 1. If the ratios 4:20 and 10:x are equivalent, can you make a guess of what x is? Is there a method you could use to justify your value for x mathematically? Now, I would like you to hold on to your answer because what I'm about to do at this stage is to establish 3 key points that will help us deal with equivalent ratios problem. The first is always convert the equivalent ratios into equivalent fractions. So 4/20 becomes 10/x. Our second key point is then to cross multiply, giving us 4x is equal to 20 times 10, which is 200. And our final key point is to divide both sides by 4. And that gives us x is equal to 50. Now, if you've got x equals to 50, well done to you. It is important that you remember the 3 key points at the bottom of the slide. So if you can take a minute or so and copy these and highlight them and try to use them whenever you're confronted with equivalent ratio problems. Unlike our previous question, where we were asked to solve for x, this question too wants us to write an expression for x in terms of y. What does that mean? Writing an expression for x in terms of y simply means to make x the subject of the formula. It's important for us to go back to our key points. The first is convert the equivalent ratios to equivalent fractions. So x over 8 is equal to 3 over y. Cross multiply is our second step. And then the final step, we expect it to divide both sides by y, and then x becomes 24 over y. I cannot overemphasize the importance of our key points at this stage. Coming back to our original question, Alice and Olivia share some sweets in the ratio of 7:3. Alice gives 3 sweets to Olivia, and the ratio becomes 5:3. How many sweets did each have initially? Now, as you can see, I have drawn 10 bars, 7 of which represents Alice, and the remaining 3 represents the number of sweets owned by Olivia. I do not know the total number of sweets, and therefore cannot tell how many number of sweets is being represented by each of these bars. So what I've done is to assign X number of sweets for each bar, meaning that Alice has now got 7X number of sweets in total, and Olivia 3X. According to our 3 key points, the first is convert the equivalent ratio into equivalent fraction. Now, if I do just that, 7x over 3x is equal to 7 over 3, I hit a wall stone. Because if you cross multiply, it will become impossible for you to find the value for x. So that means that I've got to think of another way of coming up with a second set of equivalent fractions. In order to find the second set of equivalent ratio, the information that Alice gave 3 sweets to Olivia is significant. So, meaning that Alice has now got 7x minus 3 number of sweets, whereas Olivia has got plus 3x plus 3 number of sweets. So we have a new ratio here, which is 7x minus 3 is to 3x plus 3. Okay? After the sweets transfer, there is a change in ratio from this to that, which also affects a corresponding change in the actual number of sweets from this here to that. Now, if this ratio and that are equivalent, the same, it also means that these new number of sweets and the second ratio must be the same. And if that is the case, then using the first point in our 3 key points is convert the equivalent ratios into equivalent fraction, and that will become this. The second point wants us to cross multiply. So if we cross multiply this, then we are obviously going to be left with 21x minus 9 is equal to 15x plus 15. If you take away the smaller x term, 15x, from both sides, you're then left with 6x plus 9 is equal to 15, and that gives us x as 4. So our final answer then becomes 7 times x, which is 7 times 4, meaning that Olivia, Alice has now got 28 sweets, which is 7 times 4, that's 28, and Olivia has got 3 times 4, which is 12 sweets. You can always check your answer, because if Alice gave Olivia 3 sweets, Alice will be left with 28 minus 3, which is 25, okay, is 2, and then Olivia would have had 12 plus 3, 15. If you simplify 12, 25 is to 15, you will obviously get 5 is to 3, okay, which confirms that we are on the right track. Hope this has been helpful.